This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today topic is a mean value theorem. Under the mean value theorem, first theorem is the Rolle's theorem. Actually, the mean value theorems are three types. One is a Rolle's theorem. Second one is a Lagrange's mean value theorem. Third one is a Cauchy's mean value theorem. But today we are going to discuss that first topic, that is a Rolle's theorem. Here, before going to discuss the Rolle's theorem, here what are the required conditions are satisfied the Rolle's theorem. Here, when we are going to discuss the Rolle's theorem, majorly the three conditions are required to satisfy. Whenever the three conditions are satisfied, then only the function is said to be satisfied the Rolle's theorem. Here, one of the condition is the f of x is a given function, which is a continuous function in the closed interval a comma b. Second one, that f of x is the differentiable in the open interval a comma b. And also the third condition, if f of a is equal to f of b is satisfied, then there exists at least one point c in a comma b such that f dash of c is equal to 0. Here we need to understand first of all what is the meaning of continuous, what is the meaning of differentiable. That continuous is nothing but when you are going to take the starting with any one point which is without any disturbing, that is a end point is also satisfied. That means without any different, then the function is said to be continuous function. And again, the differentiable is nothing but the function is satisfied the derivable which is exist in the interval a comma b. Here also one more point you need to remember, that is a closed interval and also that open interval. The closed intervals is nothing but including the points of that a comma b and in between the points of a comma b. And again, the open interval a comma b is nothing but which is not including the a comma b, which is satisfied inside of the interval a comma b. That means here together one of the condition f of x is a continuous function in the closed interval a comma b. Second point, that f of x is a derivable in the a comma b, that is open interval. Third condition, f of a is equal to f of b, then there exists at least one point the c in a comma b such that is f dash of c is equal to 0. If three conditions satisfied, then only the given function is said to be that satisfied the Rolle's theorem. If any one of the condition which is not satisfied, then the function is said to be that is not satisfied the Rolle's theorem. That is a clear information regarding the Rolle's theorem. Now we are going to discuss that same, that is f is a continuous in open closed interval a comma b, f is a differentiable in open interval a comma b, f of a is equal to f of b, then there exists c in b a comma b such that f dash of c is equal to 0. Here, if you are going to observe the graph of the function, if it is a x-axis and also y-axis, here a point and again the b point, here a comma b is also both are the same points at f of a is equal to f of b. And moreover, this function is means this curve is clearly without any breaking. The function is starting with a and also to b. Therefore, it is by observing this is the graph, it is clearly satisfied the function is said to be continuous and including that f of a is equal to f of b is a condition. And one more thing, it is according to the graph of the function, it is if is a function is a continuous function, that is as I said something that without any break. And again, second one is f of x is a derivable, that is by applying the differentiable is also which is existed, and f of a is equal to f of b. Then there exists, there is a condition is f dash of c is equal to, that is a c is the condition. And geometrically interpretation of the Rolle's theorem, it is also if you are going to consider f is a function, a to b, that is a comma b to r be a function which is satisfied in the three conditions of Rolle's theorem, then the graph of the function clearly here also y is equal to f of x is a continuous, is a curve in the a comma b, then it exists and also that is a unique tangent which is satisfied at every point at x is equal to c, where a is lies in between, c is lies in between a comma b. The ordinates are clearly f of a comma f of b at endpoints of the a comma b are equal to the endpoints, that is a and b, which is a equidistance from the x-axis is a condition. By the Rolle's theorem, then there exists one point x is equal to c between a and b, the curve at which the tangent line is parallel to the x-axis and also the parallel part of the curve of the function. This is the clear information regarding the geometrical interpretation of the Rolle's theorem. Here, if you connect it from f of a to f of b, which is a smooth curve also. Okay. Next one, if we are going to discuss, this is also relatively maxima and also relatively that is a minima based upon that condition. Once we are going to discuss that one problem, then easy to understand whether the function is satisfied the Rolle's theorem or not. Here, for example, if we are going to discuss this is the problem, here verify the Rolle's theorem whether it is a function is satisfied or not. The function is equal to that is a sin x by e power x, and this is also if it is a consider e power x is the denominator, that is numerator, e power minus x into that is sin x in the interval that is 0, pi only. For example, it is first we need to check whether the condition is satisfied or not. Here, according to the Rolle's theorem, f of x is continuous or not. Here clearly, while we are going to observe, it is a sin x and also e power x, both of the continuous function, because of that sin x is a trigonometric function, and moreover, these limits are in between 0, pi. It is clearly satisfied the condition, Rolle's theorem. And moreover, that is e power x, that is according to that exponential function is always that is a Rolle's theorem satisfied in the 0, pi. You take any values in between 0, pi, which is satisfied, which is does not exist, is not like that. Here all the values which are the finite value only. And second one, that f of x is that is a sin x and also e power x is also differentiable. Why? Because according to the sin x derivative of cos x, the cos x is also lies in between 0, pi, which is does not exist, not like that, which is satisfied in between 0, pi, it is a finite value. And moreover, e power x is also that is a derivable in 0, pi. Why? Because according to by taking any value of 0, pi inside of the values, which is not only finite value. Therefore, the conclusion of this part, it is f of x is there is a sin x into e power minus x is a continuous, that is in that goes into 0, pi, as well as which is a derivable in the open interval 0, pi. And the third condition, we need to check it whether the function is f of a is equal to f of b or not. Therefore, that f of a, that means here a point is equal to 0 and b point is nothing but that is a pi only. And with the help of the a, b, that f of a, that means f of 0 is equal to this 0 only, because of sin 0 into e power 0 is equal to the value of sin 0 is equal to 0. Therefore, 0 into something is also 0. Therefore, f of 0 is equal to 0. And coming to point, that is f of b, that here b is equal to pi. Therefore, sin pi is equal to also 0. Therefore, that sin pi is equal to 0 means that 0 into e power pi is also automatically 0. Therefore, the conclusion is f of a is equal to 0 as well as f of b is also 0. Therefore, together f of a is equal to f of b. And therefore, if the three conditions are satisfied, one is f of x is a continuous function, and f of x is a differentiable function, and f of a is equal to f of b. Now, our concept is whether the condition that c is lies in between a, b, whether it is satisfied or not. Therefore, with the help of this function, it is that f dash of c we need to find out. Therefore, here already that f of x is a given function. There is a sin x into e power minus x. Therefore, according to the product rule, that is a derivative, that is f dash of x is equal to, we need to find out by using the u by v or something, the product rule, that is u v derivative. By using the derivative, according to we obtain that f dash of x is equal to, that is cos x minus sin x by e power x. After that simplification of the u by v formula. And now we need to find out the f dash of c only. Therefore, f dash of c is nothing but in the f dash of x, you need to replace that x is equal to c only. Therefore, f dash of c is equal to, that is cos c minus sin c by e power c only. And again, by equating which is equal to 0, therefore cos c minus sin c is equal to, by equating the denominator is equal to 0, therefore cos c minus sin c is equal to 0. And cos c minus sin c is equal to 0 is nothing but cos c is equal to sin c. Then cos c is equal to sin c is nothing but, that is sin c by cos c is equal to 1. That is nothing but tan c is equal to 1 only. If it is a tan c is equal to 1 is nothing but, according to that values, that tan c is equal to 1 is equal to satisfied tan of pi by 4. Therefore, tan c is equal to tan pi by 4 is nothing but c is equal to pi by 4. Therefore, according to that here condition, it is 0, pi is lies in between, that is a value. Why? Because here c is equal to, that is a pi by 4 only. Therefore, pi by 4 is not is equal to lies in between 0, pi only. That is the Rolle's theorem is verified because of the three conditions are satisfied, including that is f dash of c is equal to 0. With the help of that condition, c is lies in between a, b condition. Next, we are going to discover another property, that is a condition. Verify the Rolle's theorem of the function log of x square plus ab by x into a plus b in the interval of closed interval a comma b, where for all values of a is greater than 0 as well as b is greater than 0. And here also we need to verify the Rolle's theorem, and according to here we need to verify the three conditions, that is f of x is a continuous function, or f of x is a derivable function, and f of a is equal to f of b, and finally that is f dash of c is equal to 0. C lies in between whether it is satisfied b or not. Therefore, from that, according to first one, there is a function f of x is a continuous function because of here f of x is equal to log terms, that is a log of function is nothing but log of x square plus ab minus log x minus of log of a plus b, because of log a by b is equal to log a minus log b. Therefore, with the help of the log a minus log b is equal to log a minus log b only. Therefore, based upon the condition, it is a log of function f of x is equal to log of x square plus ab minus log x minus log of a plus b only. Now, we need to find out whether the function is a continuous or not. Here, automatically the function is always the continuous function. In between, it is unknown value, that is a comma b only. Therefore, again the differentiable. According to the log x derivative is the f dash of x, where f dash of x is nothing but 1 by x square plus ab. The derivative of x is nothing but that is 2x also. Therefore, the 2x by x square plus ab, and the second one is log x, that log x derivative is 1 by x only. By solving that equation, you obtain that clearly x square minus ab by x into that is x square plus ab. Here it is exist, the derivative is also exist in the interval a comma b only. And one more thing, whether it is f of a is equal to f of b or not. And while we are going to checking here, f of a is equal to the replacement of x is equal to a only here. Therefore, log of that is a square plus ab by a square plus ab. That means here the numerator and denominator both are the same. Then by cancel the numerator and denominator, that log 1 is equal to 0. And similarly, the f of b also. While we are going to replace x is equal to b in the second one, also same value. That is a log of b square plus ab by that is also b square plus ab. And while we are going to cancel the numerator and denominator, here also log 1 only. Therefore, once again the log 1 is equal to 0. And here the conclusion f of a is equal to that is a f of b only. Because of log a is equal to log 1 is equal to 0, and second one is also log 1 is equal to 0. Therefore, f of a is equal to f of b. And here conclusion, here f is a continuous in the closed interval a comma b, f is a derivable in the open interval a comma b, and f of a is equal to f of b. And finally, we need to verify whether c is lies in between a comma b or not. Therefore, already we completed that is f dash of x, that is the value is obtained x square minus ab by x into that is x square plus ab, and with the help of that, f dash of c is nothing but replace that x is equal to c. Therefore, f dash of c is equal to there is a c square minus ab by c into c square plus ab is equal to 0. And by equating the numerator is equal to 0, that automatically c square minus ab is equal to 0. That is equal to there is a c square is equal to ab. If it is a c square is equal to ab, that is nothing but c is equal to square root of that c is equal to that is a square root of ab. That c is equal to square root of ab is nothing but which is lies in between a comma b. Therefore, it is f is a continuous function, and f is a derivable function, and f of a is equal to f of b, and c is also lies between a comma b. Therefore, here all the conditions are verified. Therefore, the given function is satisfied clearly. That is a Rolle's theorem. Next one, there is a third one. Verify the Rolle's theorem can be applied to the following functions in the interval. One is the f of x is equal to tan x in the interval 0, comma 5. And second function, f of x is equal to 1 by x square in the closed interval minus 1, comma 5. While we are going to observing this problem, first one, the f of x is clearly it is a discontinuous function. Why? Because here the function is a tan x. The tan x is not applicable at x is equal to pi by 2. Why? Because the tan pi by 2 is equal to infinity. Based upon this one, at x is equal to pi by 2, that the function is a discontinuous function. Therefore, this function is not applicable for the Rolle's theorem. Based upon this one, it is a second condition and third condition, and the f dash of c is not required to check the process. Because of if any one according to the Rolle's theorem, if any one of the condition is does not exist, almost the Rolle's theorem, which is a not satisfied. Therefore, here first condition is not satisfied because of it does not exist. Therefore, it is Rolle's theorem, it is not applicable at tan x. And similarly, the second function, that f of x equal 1 by x square also in the interval minus 1 comma 1. And moreover, this is also, does not exist at the point of x is equal to 0 because of in between minus 1 comma 1, the 0 is also involved here at the point. But according to that x equal 0, while we are going to replace in the function, that is f of x is equal to 1 by 0, that 1 by 0 is also clearly it is a infinity value. Therefore, it is also does not exist. Therefore, the meaning of here, the function is a discontinuous function. Therefore, it is also one of the conditions which is not satisfied. Hence, the Rolle's theorem which is also not satisfied. Therefore, based upon this clear observation, this first problem and second problem, these are both are the not satisfied the Rolle's theorem. That is f of x is equal to tan x in between 0 comma pi, and f of x is equal to 1 by x square in between minus 1 comma 1. Both are it is not applicable for the Rolle's theorem. Next one, it is verify the Rolle's theorem for the function that is f of x equal to x minus a whole power m into x minus b whole power n, where m comma n are the positive integers in the a comma b value. And according to here, the x minus a whole power m as well as the x minus b into whole power of n, the product of these two functions are also finally that is a polynomial function. By the property of the every polynomial function is also it is a continuous function as well as it is a derivable function in the given any interval. Therefore, it is clearly satisfied that f of x is clearly that is a continuous function in the interval of a comma b, and moreover, that f of x is also a derivable function in the interval of a comma b. Now, we need to check out whether f of a is equal to f of b or not. Therefore, in the given equation, here a point is also clearly given a, and b is also given the point is b. Based upon the f of x function, that f of a is equal to that in the given function, whenever we are going to replace that x is equal to a, the value f of a is equal to 0 because of that a minus a whole power of m, that is automatically 0. That 0 into something is also 0. And similarly, f of b in the second point, there is a b minus, there is a b is also given. Therefore, it is a 0 into something here also 0. Therefore, the conclusion that f of a is equal to f of b, both are the values are same, that is a 0 only. Therefore, f of a is equal to f of b. Therefore, if the three conditions are satisfied, that is a Rolle's theorem, that is f is a continuous as well as the derivative, and f of a is equal to f of b. Now, we need to check out what is the value of c, whether it is satisfied in between a comma b or not. Therefore, it is f dash of c is equal to, according to from the given function, when you are going to finding the derivative, that is after replacement of that x is equal to c, that is f dash of c is equal to 0. Here this function is changed to like that c minus a whole power of m minus 1, c minus b whole power of m minus 1 into that is m plus n into c minus of mp plus that is na, that whole into is equal to 0. And by equating is equal to 0 here, the first part is totally 0. The second part from that equation, m plus n into c minus mb plus na is equal to 0. And from this equation is also m plus n into c is equal to mb plus na. And from this equation, we need to find out what is the value of c only. Therefore, the c is equal to that is a mb plus na by m plus n. Therefore, by taking any value of a comma b, this is automatically satisfied lies in between a comma b only. Therefore, here first one, f of x is a continuous function, f is a derivable function, f of a is equal to f of b, and f dash of c is equal to 0, then there exists c belongs to a comma b. Therefore, according to the Rolle's theorem, here all the conditions are clearly verified. Therefore, the Rolle's theorem is satisfied. Next one, it is a function that is using the Rolle's theorem that show that g of x is equal to 8x cubed minus 6x squared minus 2x plus 1 has a 0 between 0 and also 1. Here, according to what we are observing the previous all the problems are, that is a function with the help of f only. But while we are going to observe here, it is a function is a z only. Therefore, with the help of the z, now we need to check out whether the function is a continuous and differentiable, and here g of a is equal to g of b, And if it is satisfied the three condition, then we need to find out that C is lies in between A, B, such that that is the g dash of C is equal to 0. First one, here also the function is a g of x is a polynomial function according to by the property of every polynomial function is also clearly continuous function. Therefore, here this function is a continuous function. Second function, according to the problem, the function is a derivable. The derivative is also existed. Why? Because that according to every polynomial function is also continuous function, and automatically the derivative is also existed. Therefore, this problem is a clearly function is a continuous as well as the derivative is also existed. Now we need to find out whether g of a is equal to g of b, and here a is equal to 0 and b is equal to 1. Therefore, that g of a, that means that is a 0 of 0, and that given equation when we are going to replace x is equal to 0, then automatically the g of 0 is equal to 1. And similarly, that g of 1. G of 1 is also nothing but in the given function g of x, while we are going to replace x is equal to 1, the value is also clearly 8 minus 6 minus 2 plus 1. That together the value is equal to 1. Therefore, here the conclusion that g of 0 is equal to 1 and g of 1 is also 1. Therefore, that g of 0 is equal to 0 of 1. Therefore, here the three conditions are satisfied. Therefore, the Rolle's theorem is satisfied. Now, we need to check out whether the C is lies in between A, B or not. That is according to the condition of the Rolle's theorem, that is g dash of C, we need to find out. Before going to do that, that is g dash of x is equal to, in the given function, by applying the derivative, that is clearly, first one is 24x square, minus second one is 12x, minus 2 is the third one. Why? Because the last term, the derivative with respect to x is 0. Therefore, the g dash of x is equal to clearly 24x square minus 12x minus 2 is the value. Now, we need to find out what is the g dash of c only. And g dash of c is equal to, that means we need to replace the x is equal to c. Therefore, that g dash of c is equal to 24c square minus 12c minus 2 is equal to 0. By solving this equation by using the ax square then bx plus c is equal to 0. The roots are x is equal to, we know that there is a minus b plus or minus root of b square minus 4ac by 2a. With the help of the formula, it is clearly, the values are clearly obtained at 0.63 or it is minus 0.132 also. And according to while we are going to observe here these 2 points, here one of the root is lies in between a comma b, that is 0.63 is lies in between 0 comma 1. Why? Because according to the Rolle's theorem, that whatever we are getting the c value, that c is at least 1 point, it is lies in between a comma b. Based on the conclusion, here one of the value, it is 0.63 is lies in between 0 comma 1. Therefore, here all the conditions are satisfied with Rolle's theorem. One is g of x is a continuous function, g of x is a derivable function. First one is in the closed interval, second is also in the open interval, and g of a is equal to g of b, and the g dash of c is equal to 0 such that c belongs to a comma b. Hence, it is also the function is clearly satisfied, that is Rolle's theorem is verified. Now, again, we need to find out whether the function is Rolle's theorem or not in the interval 0, 8. Therefore, here also consider the function is x power of 2 by 3 minus 2x into 1 power of 1 by 3. And it is also, while we are going to observe it, it is also clearly the function is a polynomial in the interval of, that is 0, 8. It is also clearly satisfied. And again, the derivative, by applying the derivative, it is also clearly satisfied. And again, in the interval, by taking that any value of 0, 8 satisfied. And the third condition, we need to verify that is f of 0 is equal to f of 8 or not. Where f of 0 is equal to, that is a function is clearly 0 minus 2 into 0, automatically the total one is 0. And similarly, f of 8, and f of 8 is also at the point of x is equal to 8, that is 8 power of 2 by 3 minus, that is 2 into 8 power of 1 by 3. It is also the value is 4 minus 4 is equal to 0. Therefore, it is f of 0 is equal to 0, f of 8 is equal to 0. Therefore, f of 8 is equal to f of 8. Therefore, here the three conditions are clearly satisfied with Rolle's theorem. But we need to find out whether the c is lies in between a comma b or not. That is 0, 8 is lies in between or not. Therefore, once again, when we are going to find in the f dash of c is equal to 0, here by using the derivative from the given equation, there is 1 by c power of 1 by 3 minus 1 by c power of 2 by 3 is equal to 0. By taking the LCM and again cancel, cross multiply, and again by simplification, finally we obtain here C is equal to the value is equal to 1. Therefore, that 1 is nothing but it is lies in between 0, 8. Therefore, according to it is clearly the Rolle theorem is satisfied because of f is continuous in the closed interval, f is a derivable in the open interval, and f of a is equal to f of b, and moreover, there is a dash of c is equal to 0. Then there exists c belongs to a comma b such that satisfied. Therefore, it is also function is satisfied the Rolle theorem. Next one, it is a function is a Rolle theorem or not. That is f of x is equal to x into x plus 3 into e power of minus x by 2, the provided the limits are minus 3 comma 0. Here also the function is a clearly polynomial function as well as every polynomial function is also continuous function in the interval of that is a clearly satisfied minus 3 comma 0. Second one, the function is a derivable and it is also derivative is also existed. Therefore, why? Because it is a product by applying the product and again the derivative, that f dash of x is equal to e power of minus x by 2 into that is a 6 plus x minus x square by 2. It is also does not become infinity. Why? Because by replacement of any value of minus 3 comma 0, which is not a 0, not infinity condition is satisfied. That means it is a obtained finite value. Therefore, it is f dash of x is also derivable. And we need to check out whether f of a is equal to f of b or not. Therefore, f of a is nothing but that is f of minus 3. Therefore, in the equation, while we are going to replace that in the given function if x is equal to minus 3, the value is going to clearly 0. And here the point is b is equal to 0. Therefore, according to the function, that is f of 0 is equal to the value is a 0. And finally, it is a f of minus 3 is equal to 0, f of 0 is equal to 0. Therefore, f of minus 3 is equal to that is a f of 0. Therefore, if the three conditions are satisfied, Rolle theorem. Now, our concept is whether C is lies in between A and B. And for that, we need to find out what is the f dash of x. Therefore, f dash of x is equal to, you obtain that clearly, there is a C, 6 plus x minus x square. But we need to find out that x is equal to C. Therefore, f dash of C is equal to 6 plus c minus c square is equal to 0. By solving that, we obtain that c is equal to clearly 3 comma minus 2. And while we are going to observe these 2 points, here the given function limits are minus 3 comma 0, but here we obtain the values of 3 comma minus 2. By observing these 2 points, here 3 is not lies in between the given interval, but it is minus 2 is the one of the point is lies in between the given function. Therefore, according to our Rolle theorem, at least one point which is satisfied in the given interval. Therefore, here the Rolle theorem is clearly satisfied. Why? Because the function is a continuous function in the closed interval a comma b, and f of x is the differentiable in the open interval a comma b, and f of a is equal to f of b is satisfied. And moreover, f dash of c is equal to 0, such that there exists c belongs to that a comma b is also satisfied. And again, here the function f of x equal to x power 4 minus 2x square on the interval minus 2 comma 2. Here the function is a continuous as well as it is a differentiable. Because of here the polynomial function given the given function, therefore the function is continuous as well as it is a differentiable. And f of minus 2 is equal to the value is clearly 8, but according to that is a replacement of x is equal to minus 2, the value is equal to minus 2 whole power of 4 minus 2 into minus 2 whole power of square. Then the value is 8. And similarly, that f of b is also that is a 2 power 4 minus 2 into 2 square, the value is equal to 8. Therefore, at the conclusion, f of b is equal to f of b. Therefore, now we need to apply that is f dash of x. Therefore, f dash of x is equal to that is a 4x cube, 4x is equal to 0. Therefore, x is equal to minus 1 comma that is a 0, and also that is a 1. Why? Because it is the value is equal to 4x into x square minus 1. That means it is a 3 roots are 1 is a minus 1 and 0 and also 1. While we are going to observing this function, the function is a given function limits of minus 2 comma 2, and here according to here all the values are satisfied, even though it is satisfied the 0. Second one, it is a function is a f of x equal to 4 minus x square, and again it is also minus 2 comma 2. Whether the Rolle theorem is applied, if not, why not? If so, find the value of c only. Here also the condition is clearly that f of x is a continuous function, and also the function is a derivable function, and also we need to find the value of 0. Next one, the function f of x is equal to clearly whether it is a continuous function or not. Is the function is a continuous function minus 1 comma 1, but it is not a differentiable at the point of 0. Why? Because it is at the point of at x is equal to 0 that LHS limit is equal to minus 1, but whereas it is RHS limit is equal to plus 1. Because according to the first principle, when we are going to replace x is equal to that is a 0, that LHS limit is a function is a minus 1, but RHS limit is equal to plus 1. And if it is a RHS limit and LHS limit both are the not same equal, then automatically the function which is it does not exist. Therefore, it is clearly the function is not applicable for the that is Rolle's theorem, because of it is not a differentiable at f of function. But even it is f of minus 1 is equal to f of 1 is also not satisfied. And one other condition, f of x is equal to x squared plus 4 by that is x squared. The limits are in between minus 2 comma 2, whether the Rolle's theorem can apply or not. Here clearly the function it is not applicable. Why? Because that it is a minus 2 comma 2. One of the point is lies in between 0 is a point only the condition. It is the point is going to clearly satisfied 0. But when you are going to replace that x equal to 0 here, the function is equal to it is infinity. Therefore, if the function is infinity, is nothing but it is a differentiable, that is a not a derivative, it is not a exist. Therefore, it is Rolle's theorem which is not applicable. And again, similarly, whether the function is a Rolle's theorem it is satisfied or not, it is a function is clearly the function is satisfied the continuous function, right? Because it is given the function is a polynomial function. According to the concept, every polynomial function is a continuous function in the given interval a comma b, that is a minus 1 comma 3, and differentiable is also clearly it is satisfied. Why? Because that every polynomial function is a continuous function as well as a differentiable function. Why? Because it is does not satisfy, that does not infinity, not like that, it is a finite value only we obtain. And again, next one, while we are going to find out whether the function is a Rolle's theorem or not, there is f of x is equal to that is x minus 3 into x plus 1 whole square on the interval that is minus 1 comma 3. And here also we need to find out whether the function is a continuous Rolle's theorem or not. Here the function is clearly from continuous function because of it is also given the function is a polynomial function. Therefore, every polynomial function is also a continuous function. In the given interval certain there is a minus 1 comma 3. And second one, the function is also derivable exists. Therefore, it is also differentiable in the interval of minus 1 comma 3. And moreover, f of a is equal to f of b also, because of f of a if a is equal to minus 1 from the given function, that is f of minus 1 is equal to the value of 0. And also that f of b, that means that is f of 3 is equal to the value also 0. Therefore, here the three conditions are satisfied the Rolle's theorem, because of f is continuous in the closed interval, f is a differentiable in the open interval, and f of a is equal to f of b. Now we need to find out whether it is applicable or not, that is a c belongs to a comma b. Because of that one, therefore f dash of c is equal to 0, we need to find out. First of all, that is f dash of x, we need to find out that is f dash of x is equal to that is x minus 3 into 2 into x plus 1 plus x plus 1 whole square into 1 by applying according to the product rule, that is uv dash plus mu dash. And finally, that f dash of x is equal to the equation is we obtain x plus 1 into 3x minus 5, and by equating 0, that is x plus 1 into 3x minus 5 is equal to 0. Therefore, one of the point is x is equal to minus 1, and second point is x equal to 5. And again here, while we are going to observing, the point is c is lies in between a comma b, but according to this one, it is minus b is not within the interval minus 1 comma 3, because of it is minus 1 is including, but the Rolle's theorem it is lies in between the a comma b satisfied, but it is minus 1 is not inside of the point. And again that 5 by 3 which is lies inside of the points, because that 5 by 3 is lies in between minus 1 comma 5 by 3. Therefore, here one of the point is satisfied in the given interval a comma b, that is a minus 1 comma 3. Therefore, here the Rolle's theorem is clearly satisfied. One is f is a continuous in the interval closed interval a comma b, f is a differentiable in the interval a comma b, and f of a is equal to f of b, and f dash of c is equal to 0, such that c belongs to a comma b. Based upon all these conditions, here the function is satisfied. That is a Rolle's theorem. Next one, verify that f of x is equal to x cube minus x square minus 6x plus 2, whether it is satisfied the hypothesis of the rule theorem for the interval 0, 3. Then find all the value of c to satisfy the conclusion. Here, the first of all, we need to check to see that rule theorem applies. The first one is f of x is clearly satisfied the continuous function because of the given function is a polynomial function. Based on the property of that, every polynomial function is also the continuous function in the interval closed interval 0, 3 here. And again, the differentiability is also satisfied according to by applying the derivative. It is also existed. Therefore, in the interval 0, 3, it is a differentiability existed. And f of a is equal to f of b. That means f of 0 is equal to 2 here. And f of b is equal to the value is equal to f of 3 is also is a 2 value. Therefore, it is a continuation. The problem is a over. Therefore, the function is satisfied the Rolle's theorem. Therefore, conclusion of this session, the function is says something the Rolle's theorem. The three conditions are equally satisfied. One is a continuous function in the closed interval a comma b, the differentiable in the a comma b, f of a is equal to f of b. Then there exists c belongs to a comma b such that f dash of c is equal to 0. Based upon these three conditions, including c belongs to a comma b, then only the function is satisfied the Rolle's theorem.
Like, share and subscribe. Hit the bell icon for more updates.